In lesson 2.1, we learned how to do additions and subtractions with variables. In lesson 2.2, we go a step further and we learn how to do multiplications and divisions. But before we can do multiplications and divisions, we need to remember two important properties of exponents. To the left of the screen, we have multiplication of exponents with the same base, in which case we take the base, we're going to copy that base and merge them into only one base, and then we add the exponent. So we have m, we write m, and we add it plus n. Then we also have division of exponents with the same base, and the process is very similar. We take the base, we're going to copy that base and merge them into only one of them. And for multiplication, we did addition. For division, we do subtraction. But for division, it's very important we follow the correct order. We always start with the exponent of the numerator minus the exponents in the denominator. That's why we get m minus n, because we have to always do the numerator minus the denominator in that order. Let's put this into practice, starting with a couple of examples of multiplication. To the left of the screen, we have x to the power of 3 times x to the power of 2. Both of them have the same base of x, so we can merge them into only one of them. And then we add the exponents, which is 3 plus 2. And 3 plus 2, this is just 5, so we get x to the power of 5. And this is how we can simplify. To the right of the screen, we see a problem that looks harder, mainly because of the coefficients of 4 and 3. But let's start with what we know. Beginning with the fact that this x don't have a written exponent, do not make the mistake of saying the exponent is 0. The exponent is actually 1, always. When a number or a letter don't have a written exponent, it means it has an exponent of 1. Now let's do what we know. They both have the same base, so we can just copy the bases, merge them into one base, and add the exponents. We know this part. Now we have to deal with the coefficients, with the numbers. And for this, we need to remember that we always multiply variables with variables, as we just did. X to the power of 5 times x to the power of 1 is x to the power of 5 plus 1. And then numbers with numbers, so we multiply the 4 and the 3 together, leaving us with two multiplications. 4 times 3 of the coefficients, and 5 plus 1, which is a multiplication of x to the power of 5 times x to the power of 1. 4 times 3 is 12, 5 plus 1 is 6. We get that this is 12 times x to the power of 6. Now let's take a look at a couple of examples with divisions, starting at the left, where we have x to the power of 5 divided by x to the power of 2. We're just going to copy or merge the x's into 1 and then subtract. Remember, starting with the numerator, so that's why we start with the 5 minus the denominator, 2. So always numerator minus denominator. X to the power of 5 minus 2. 5 minus 2 equals 3. And we get x to the power of 3. Then if we look to the right of the screen, it seems harder, again because of the coefficients. But let's start with the fact there is no written exponent here. So let's make an exponent of 1, always. If you do not see a written exponent, it means it is an exponent of 1. Let's do what we know. The bases are the same, so we can just merge them into 1 and then subtract the exponents. Always subtracting the numerator first minus the denominator. That's why we have 5 minus 1. Then we look at the coefficients of 12 and 3. Same with the division, we're doing it with the division. Same with the multiplication, we do with the division. We always divide variables with variables. That's how we got x to the power of 5 divided by x to the power of 1, which gives us x to the power of 5 minus 1. And then numbers with the numbers, leaving us with 12 divided by 3. So we have two divisions, 12 over 3 and x to the power of 5 divided by x to the power of 1. That's how we get the 5 minus 1. 12 divided by 3 is 4, and 5 minus 1 is also 4. So we get 1 over 4 times x to the power of 4. But we can actually simplify a bit further, because this is x to the power of 4 divided by 4.